Okay, so for the next one, notice I'm only just doing one. I don't have to do all four inequalities. So for the graphing method, I first make sure that it's equal to 0 on one side, and it is. Then I set f of x to be equal to the polynomial, so we could just deal with it in polynomial form. And I need that factored. So I'm going to factor out a -1. And then factor that again. X minus 3, x minus 1. That tells me that my zeros are at 1 and 3. From my original polynomial, my degree is 2 and my leading coefficient is -1, which tells me my end behavior from an even degree and a negative leading coefficient is down and down. I can graph this pretty quickly with, we have x-intercepts at 1 and 3, and the end behavior is pointing down. So I know that it has to come up and come down. That's what quadratics do. Okay, so let's identify where is the graph above the x-axis and where is it below. So it starts below, then it goes above between 1 and 3, and then it goes below after that. Notice that right on the x-axis they're at 0, okay? Those are little zeros. So my inequality is f of x, where is f of x less than or equal to 0? So I'm trying to find out where is that satisfied. Where's my function less than or equal to 0? Well, in this case, less than is below, which is the negative section of my graph. So the answer to my solution would be all the x values from 1 and to the left. So that's -infinity till 1. Do I get to include the 0? Well, in this case, yes, I do. Union with 3 to infinity. Again, I get to include the 3. You can never include infinities. Let's do that same problem using the sign test. So the first thing I want to do is write f of x is equal to my polynomial. I still have to do the factoring. So because I just did it, I'm not going to spend a lot of time here. I'm just going to write the factored solution because I just did it on the last problem. If you were to only do the sign test, you'd have to still factor, okay? What are the zeros? The zeros are 1 and 3, which create my boundary points. So now I have 3 intervals that I'm working with. To the left of 1, between 1 and 3, and then to the right of 3. So I need to find f of a value between each one of those boundary points. So in the first interval, I need something to the left of 1. Well, 0 is my favorite number that I can plug in, so if I ever have an interval that has 0 in it, I'll choose that. So when I find that out, I'm going to either plug that into the original or the factored. It should work either way as long as you factored correctly. So 0 squared plus 4 times 0 minus 3 is -3, which gets me negative in that whole boundary. That one point will tell you where the whole boundary is above or below the x-axis, because the 1 and the 3 are the boundary points. Those are the only places where it can cross the x-axis, so everything in that one interval will still be negative. So I need to pick something between 1 and 3, so I'll pick 2. So I'm getting -2 squared. Notice the negatives on the outside of the parentheses, so that's -4 plus 8 minus 3, that's 4 minus 3, which is 1, which is positive. So that whole section will be positive. And then I need something to the right of 3, I'll pick 4. -16 plus 16 minus 3 is negative. Okay. So now that I have the section, I'm looking for where is my graph satisfied? Where is my inequality satisfied? Where's my function f of x? So I'm looking for where is f of x less than or equal to 0. Less than or equal to. Less than is negative, so that whole section includes 0. Less than, and then includes 0. Okay? So now I'm going to answer the solution in interval notation. So that's -infinity up till 1, include it, union 3, include that, to infinity. Again, notice that the answers are the same. the work is different. If it was up to me, I would probably pick the graphing method. For me, it's really much simpler just to graph the whole line and then plug in the values, but either method will work. On this next problem, notice we have two of the same functions. F of x is equal to x squared minus 2x plus 1. When that's factored, I get x minus 1 times x minus 1. I'm asking two different inequalities. F of x is greater than 0. Where does that happen? And where is f of x less than or equal to 0? So I have two questions. I'm using the same graph just to get more bang for my buck here. My zeros will be at 1. But this has multiplicity, doesn't it? Multiplicity of 2. The degree is 2, the leading coefficient is 1, that means it's up and up. So at 1, what happens? Well, because it's a multiplicity of 2, it's going to come, touch at 1, and turn around. So my question is, where is things positive and 0 and negative? So I have positive to the left of 1, 0 at 1, and then positive to the right of 1. So I really don't have any negatives. Well, let's see what happens here. The first inequality says, where is my function greater than 0? So it's greater than 0 here on the right. It's greater than 0 here on the left. But am I allowed to include the 0? Well, in this case, no, I'm not allowed to include the 0. So my solution is negative infinity up until 1, not including 1. Union, starting at 1 again, but not including 1, up until infinity. Basically, that means all the x values in the whole entire world except 1. So the next question says, where is my f of x less than or equal to 0? Now, there's nothing less than it. There's no negative parts. But there is one spot that it's equal to 0. So the one spot that it's equal to 0 is the solution for that inequality. So the solution is just the one spot at 1. Because there's not an interval, it's just a one value, we use braces instead of interval notation. On the next problem, notice it's the same function, although I changed up the inequalities just to give us a little variation. So my function is still the same, f of x. And when factored, it's still the same, which gets me a boundary point at 1. Now it is multiplicity of 2, but in this case it doesn't really matter. You just have to put the one boundary point there. I need to value the function at points on both intervals. So there's an interval to the left of 1, so I'll do f of 0. Which gets me positive. I notice already at 0 at 1. And now I need to find something to the right of 1, so I'll plug in 2. I need you to remember that there could be lots of things that you could plug in, an infinite amount of things. I'm just plugging in the smallest one because I'm lazy and I don't like big numbers. Okay. So for this next problem, I'm trying to find out where is my function f of x greater than or equal to 0. Greater than or equal to 0. Well, greater than, that's positive things, so those work. Or equal to means I also get to include the 0. So what am I not allowed to include? Well, nothing. I get to include everything, which means my solution is actually all real numbers. Notice this is not the same problem as before. It's or equal to versus greater than. So it's different answers, okay? On my next problem, I have f of x is less than 0. Where is f of x less than 0? So less than 0. Where on my graph do I have anything that's less than 0 but not equal to it? Well, I don't have anything that's exactly less than it but not equal to it. So that one means that there is no solution. There is no place on the whole graph that my function is strictly less than 0.